Hello everyone, you are welcome to this YouTube channel. I want to show you the principles of FM transmitter, how it works and how you can do yours if you so desire to make one today. So there are several components that can make this a reality. The first and the most important one is a microphone. This type of microphone is called a condenser microphone. It receives sound signal, and it turns that sound into electric impulses, electric signal. In other words, in an electronic or electrical term, we call it modulating signal. That is the signal that we want to modulate. So this is the device that produces that signal. All right. So moving ahead, we'll be using a capacitor. This is a ceramic capacitor. Look at it very well. It is 104, that is 10 times 10 raised to power 4, or let me just say 104 picofarad. 104 picofarad. So all the capacitors are of the same capacitance. All right, now I'm going to show you why we need three. We only need one to work with this microphone. It's going to be used to filter noise out of this modulating device. Let me put it that way. But the remaining two are going to work with this regulator. This is a regulator. It's not a FET. It may look like a FET, but it's not. It's a 5 voltage regulator. 7805. 5 voltage. All right. So the two capacitors that remains are going to help to create a balance by the time we are giving it a particular voltage as an input and the output. It helps to balance both input and output. The middle terminal is a ground. So the first one here is the input, the here is the output. All right. So going from there, here is a 4.7k resistor. 4.7 yellow in the resistor code is 4, 7 is purple. 4 7 times 10 raised to power 2. So that's 4700, 4.7 kilo ohms. We have 100 ohms resistor be used to connect the emitter to the ground. Right, a light emitting diode. Then we have two 22 picofarad, the ceramic capacitor, 22 picofarad capacitor. Then we have a which is very germane in this practical. You must have a coil for the system to really to work. Now we have the core, the core part of this project, which is a BJT transistor. We could use any N transistor, but I've decided to use BC547. Probably because of its availability. So that's why I've decided to choose to make use of BC547. I'm trying to make you see the name, but it's BC547 for those who can see it. Now we have a switch, and then we have 9-volt battery and 9-volt battery connector. All right, let's go ahead now to the schematic. This is a simplified diagram of the FM transmitter circuit system. This FM transmitter is powered from above. The power is above, the transmitter is below. In other words, they connect to the transmitter. That's just what I'm depicted here. So the amplifier itself, I also like to divide into three different stages. With all those components I showed you earlier, I'll just be dividing into stages. We see where the input, where the amplifier, and where the output is, where you can take your output and where you can store your input, and also the power impact on the meter. We come to know that when the power is having difficulty in a frequency also. So let's move very briefly. Here is the circuit. Remember, I showed you the condenser, the filtering capacitor, the 100 ohm resistor that connects to the ground, then the capacitors around and the inductor. This is the voltage that I talked to you about. And the two capacitors that helps to balance it. Here is a LED, indicates when it's powered or not powered. is a switch that's used to control so that the battery power will be preserved. Here is the terminal connector. All right, this is the antenna. I use just another. Sometimes it will be the wire. Anyways, I use the wire as my. So let's go and see the schematic of the system. All right. Once again, this has three different components. Components, but the transmitter itself, I earlier, can be divided into three different. Coming here is the indicator, the LED, the light emitting the other time. Here, here is it here, and then the resistor that limits the current passing through. This resistor must be high enough to receive enough power for the whole system. It must be very high, such that little current will flow through it. It's just for the purpose of lightening this indicator, so it must not be too bright, just very little, so that we can have enough power for the whole system. Right. So this is the battery, 9-volt battery. Is the switch. When you close this switch, power begins to flow in the whole circuit. When you open it, power is kept out of the circuit. 7805 voltage regulator. First capacitor in the input, second capacitor in the output. Also at this same output is the output going. This output, goes directly to the input of the transmitter. All right. So here it is a ground. So let's leave the power section now. I hope you understand everything in this power section now. So let's go down to the transmitter proper. All right. So the microphone condenser receives signal. So it receives sound and it turns that sound into electric impulse, which comes here, which gets to this place, and then when it gets here, it is added together to the signal coming through this resistor. So the two of them are added together. From here, they become the modulated signal, which is then fed to the base of this transistor. So, in other words, this section is the input. Everything here is the input. Here is our amplifying section. The amplifier is the transistor here. It amplifies the input signal by allowing a bigger current to flow. Because you remember the working principle of a transistor is that it allows big currents to flow as a result of a small current being applied here. Because this modulated signal is so small, we can't just transmit it like that. We need a bigger signal that somehow corresponds to this modulated signal, so that we can get the same information out, but in a amplified fashion. So this is the amplifying. So the transistor and these few resistors and capacitors are the amplifying stage. So the frequency producer, the major frequency producer, is this capacitor and this inductor, which are in parallel. If you the relationship between the two of them, the moment the capacitance and the inductance is equal to each other, then we have our frequency to be at resonance, which means frequency is equal to 0. But if they are not equal to each other, if this increases and this remains constant, our frequency will not remain the same. It will not be 0 anymore. So they must not be equal if we are going to have a particular frequency. If our F is not going to be equal to 0, then X of C must not be equal to X of L. That is, the capacitive impedance and the inductive impedance must not be equal. So when they are in parallel, like this, then we are going to have something like 1 over 2 pi FL, which is equal to 1 over 2 pi FC, which is equal to 2 pi FL. By the time we collect like terms and we make F the subject of formula, so we will be able from here to get out the value of our frequency by resolving this equation. All right. So our frequency depends majorly on the value of either of the two of them. Now, in my own design, I've decided to make use of a constant capacitor. It is likely you see other designs where variable capacitors are used. Yes, it is possible. But being a simple designer, we are not willing to be changing the frequency every time. We will just make it a constant capacitance. The value will be constant. I decided to use 22 PF. That is the essence of those small brown capacitor I showed you earlier, 22 PF. So the capacitor here will be 22 PF. Same also with the capacitor here, which is 22 PF. This is the inductor. This inductor is going to be the one now. Since we already shows the value of this, we are going to wind our inductor to give us an inductance that when we put it into this formula, it will be able to provide the particular frequency that we want. Let me explain that a little bit further. So let me now resolve these two equations such that we'll be able to have the value for our frequency. So by the time we multiply this with this, we have the final answer will be 2 pi root of LC. L will be the value of the inductor, C be the value of the capacitor. Take the square root of them, multiplied by 2 pi, then divide 1 by it. So this will give us the value of the frequency. Let's now imagine that we want a frequency of 100 megahertz. So that means already we have our frequency. Then we are going to get the value of our inductor. Now we fix our capacitor from here to be equal to 22.4. So 22 times 10 raised to power minus 9, because picofarad, pico is minus 9. Then we multiply it by the value of the inductor. Now we do not know the value of the inductor because we don't have an inductor yet. So we are going to make our own inductor. But then we want to know the value of the inductance we are going to make for us to get a frequency of 100 megahertz. All right. By resolving this equation, our inductance is going to be L is equal to 1.15 times 10 raised to power minus 7 farad. I mean Henry, because inductance is in Henry. So now we've discovered the value of the inductance. The reason why we are getting inductance is because we've already fixed our mind on a particular frequency, such that by the time we open our radio and we want to receive our signal, we just tune into 100 megahertz. So we have also fixed the value of our capacitor, probably because that is what we have. We don't have other capacitor. We have only 22 PF. So we only need to now alter the value of our inductance. So putting it into this, we get our inductance to be 1.15 times 10 raised to power minus 7 Henry. I will now be showing you the formula, the formula you need to use in order to calculate how to wind your inductance. After that, we should be done. I mean, we have very few more to discuss on this topic. So to get our number of our how to make the inductor. Inductor is made up of wire that is wound around a particular shape. It could be a circular shape. It has usually been a circular shape. If you remember I showed you earlier, let me look for the inductor now. Here is it. You see, I had to wound it around my pen, the ink of my pen. You understand? I mean, the pen inside the container of the ink. So I had to wound it around it. That's the diameter I used. So knowing that diameter, it will be easier for me to calculate my inductance. So let me write that here. Should it later. This is inductance is equal to, this is a constant. Mu R is a constant times 10 ton squared times multiplied by the area of the object you are wounding it around, all divided by the length, I mean how long you want it to be. That's the length. Now multiply it by 1.126 times 10 raised to power minus 6. In some instances, mu r, which is the permeability or relative permeability, is usually equal to 1. So is 1 because our object, the shape we are wounding it around is here, because eventually we will remove the ink. For example, I use the ink container. I will remove the ink container, so it will be here alone that will be inside. So look at this now, there is no container inside. So the relative permeability of here is equal to 1. Okay, so by the time we get that, we also calculate the area of the objects we are working around. For example, the area of what I used is ink, which is pi r squared. So when you get the diameter, you get the radius, then you multiply by pi and you square the radius, you get the area to give us this area. And then you know the inductance. Don't forget that here we had already got our inductance. So what we are looking for now is our number of turns. Since we can calculate our area and we can decide our length, we just look for how many times we want to wound it around that shape. So we just make number of turns subject of formula. So when we do that, we get the number of turns, and that was what I did to get this inductor. So since I felt that was easy to do than to be looking for capacitors all around, sometimes those feedable capacitors are not in the market, especially in this part of the world. So you can't get some of those capacitors. You have to go and open other electronics to do that, to get it. So we can just adjust our inductor to our own particular desire. All right, let's come back schematic the schematic diagram we have here. So the last now, I'm not talking about the antenna. The antenna. The antenna is usually not so very important in this design because before after the circuit, I had the antenna and I was able to receive signal. So it's also possible you don't usually need the antenna, but we put the antenna here. Ordinary wire as the antenna. That's acceptable. So just to do a brief of what I've discussed in this section, I've talked majorly on the power section, how to regulate it. Now, the reason why we regulated it, let me quickly mention that, is because if we do not give it a regulation, that is, if the output is not always constant, let's say constant 5 volts, the frequency will be changing also. So you know we had already chosen 100 megahertz here. The moment our voltage begins to drop, our frequency also will begin to drop. So we won't have a constant frequency. So in order to avoid having a very varying frequency that will now be looking for frequency up and down, searching for frequency on our radio, that's why I included the voltage regulator section. So it gives us a constant voltage. Even if this 9 volts is dropping to 7 volts to 8 volts, it is still able to give us 5 volts constantly. Do you get that idea? So that's the reason I included this segment, and this LED is just to show us, when we have switched the power on. When we close the switch, the LED will turn on, indicating that now we are on. So when we know we are on, then we can begin to use our FM transmitter, and anywhere it is being used, we can receive signal on our radio. All right. Thank you. In the next few seconds now, I will just practicalize the one I've made and show you how it works. Alright, once again, here is the antenna. The switch is here. Alright, now I press the switch. I believe you could see there was a change in the intensity of the LED above it, on it. Alright, the LED is on now. So I could decide to speak into it. I'm coming. Let me do it in a way that you can hear it. Now I've brought a phone into the system now. Alright, so see the microphone. I don't want to hear the sound from other source, so let me do it. Now it's talking. I don't know if you hear it. So to get this, taking it the phone or the signal from 106.2. Thank you for watching. If you have any question, I would like to drop it down in the link below. I mean in the chat box. If you have any question, please drop it, and I will advise subscribe and video with others who have interest in this project. Thank you.